Hi everyone. I wanted to take a few brief minutes to just discuss your test on Monday. So in reminder, you do have test number 2 for pre-cal with trig on Monday the 15th and at starting at 9:30 a.m. It is scheduled for the whole class period. Now, what I want to do today is really just run through the topics. We're not going to work a whole bunch of examples, but I want to run through the topics you'll expect to see. So first, it starts at Module 3B. Module 3B is all the trig graphs. So graphs of sine and cosine. It also includes Module 4, which is the average rate of change. Module 5, which is quadratics and bigger polynomials. And the start of Module 6. So we will go through Module 6 where we left off last Monday, which means going through power reducing formulas. As far as homework, before we get started with the test review, trig graphs and average rate of change were already due. So if you haven't completed those, you're on the late 70% at this point, but you can still work on them. Quadratics and polynomials, Module 5, is due Sunday night before the test, so make sure that you work on that. Module 6 on web work is not due until the 21st. Now the first 13 problems on that are what corresponds to this test. After that, there will correspond to the next test. So I extended the due date. If you want practice, you can go work on those problems, but they're not due until after the test. Moving forward, as far as what to bring, make sure you bring your non-graphing calculator. And make sure you bring a pencil or some other sort of writing utensil that's not red. Other than that, just bring yourself and bring your brain and we should be good to go. As far as what you should expect, I'm going to go through kind of module by module to narrow down your study focus. These are not specific problems, they just give you an overall idea. So from Module 3B, you should expect a couple of problems where you have to graph a trig function, and think of one that's basic. And by basic, I mean something like y is equal to 2 cosine of maybe 2x. So something where maybe the period is altered, maybe the amplitude is altered, but not everything all at once. Anytime I'm asking you to graph a trig function, it will be like your lab sheet. So you will be asked for the amplitude, the period, the phase shift, and the midline. I'll step you through it just like that. And also you will have a blank axis. So you will have to label your axis and get those points on the primary period. Remember that whatever your period is equal to 2 pi divided by b, and your b term is whatever falls in front of the x. Now if you're looking for how often you have to make hash marks on the axis, remember that your axis marks come at every period divided by 4, since there's 4 of them. So that is what I consider a more basic one. You'll have one basic and one more challenging. As far as what I consider challenging, that means that we're altering more than one thing. So something like y is equal to negative cosine of, say, 2x plus pi over 2 minus 3. So this is something that's more challenging. We have a flip in here. We have a phase shift that you have to factor out first. We also are altering the midline. So remember that when you approach this, you should factor first. I will post a separate video that is a graphing video of a complicated trig function in case you want to look at it. So that will be also posted. All right, so that's it for Module 3B. You'll have to graph a couple of functions. Now, moving on to Module 4, average rate of change. Really, Module 4, I'm going to ask you to just find the average rate of change of a function. So the review questions that are like this are questions like 1 through 4. Moving on to Module 5. You will have to work with a quadratic. So you're going to have to take a quadratic like f of x is equal to negative 3x squared plus 5x minus 2. I just made that one up, so it could be anything like that. As far as what I'm going to ask you for, I'm going to ask you for the vertex, the axis of symmetry, the intercepts, could be x and y, and then I'm going to ask you to graph it. So your homework has stepped through all of these things, and really finding the vertex, the axis of symmetry, the x and y intercepts, it'll help you graph it. So all of those things you should put together for the graph. You'll also have an applied quadratic. And remember that the applied quadratic functions are really, when you're asked for a maximum or a minimum, that really is the find the vertex in disguise. Because we're dealing with a parabola, and that maximum or minimum value is always the peak here. So like your hands-on lab with the parabolas, you'll have something like that on the test itself. Moving along to the second half of Module 5. Second half of Module 5 are higher order trig functions. So you will have to graph something that is given to you in nice factored form. So I want you to take a polynomial in factored form and graph it. So it could be something like f of x is equal to 3x times x minus 2 to the 5th times x plus 1 to the 4th, and so on. So things you have to know to get this done: you have to be able to find the zeros, the multiplicities, and the behavior. So remember that if we're talking about zeros, it's where the value either touches or where the function either touches or crosses the axis. So this thing 3x gives us an x equal to 0. Multiplicity is the power on that particular 0, so this one would be a multiplicity of 1. And remember that odd crosses, even touches. So it goes through like that. Now, if I'm talking about this kind of graph, you also need to know the end result, the end behavior. So that's based on the degree, overall degree of the polynomial. So looking at this degree, I have 1 from this one, 5 and 4, so this is a degree 10 overall. And the leading term is positive, So that means that it's a right side up even degree. Just a little review for the degrees of the polynomial. If it's positive and even, then they all look something like a parabola, right side up. If it is negative and even, then it's flipped over the x-axis. If it's positive and odd, then it comes in from the bottom and exits out the top. And if it's negative and odd, then it comes in from the top, exits out the bottom. Once you figure out your zeros, multiplicity, and end behavior, then you'll have to put it on a graph. You will also need to deal with the zeros of a polynomial. So think synthetic division. You'll have to list possible zeros, find the zeros, and factor. So those are the things that you'll have to do with a polynomial. So I'll either give you a 3rd degree polynomial to do this with, or I will give you a 4th degree and give you a clue. So one of those two things will be true. And these are like 26 through 28 of the review. All right, on to module number 6. As far as module number 6, you'll have a couple of things. Module 6, you will have some identities. And included in the email that I'm going to send you with this video will be a list of identities that you have to know and have to have memorized. I mentioned in class the other day that, or last week on Monday, that you will have 3-ish identities to work on for the test. One that I consider pretty straightforward, one that I consider a little more challenging, and one that's pretty challenging. So if you're looking at, for examples, these are numbers 46 through 52 on the review. As far as stuff that's basic, I'm talking about like number 46. Stuff that's a little more challenging, like 47. And stuff that is much more challenging, like 51. So be on the lookout for some actual functions like that, or some equations to verify. The last type are the ones that you need formulas for. So look for a sum and difference. So find a value of like tangent of pi over 12, something like that. And you'll also have to do something like a double angle. So like find cosine of 2 theta given sine of theta or something. And those, as far as the formulas are concerned, those are like 53 through 56 and 57 through 60. All right, that's about it for topics. I will be checking my email on Sunday, so if you have any specific questions, please feel free to email them to me, and I will get back to you before Monday morning. Thanks. Have a great weekend.